We think we know the moon. We've looked at it our entire lives. A pale ghost hanging in the night sky, silent, familiar, safe. Most of us carry a quiet assumption that it's been mapped, studied, and understood. That the mystery is gone. That the moon is, in essence, a solved problem. That assumption is wrong. Dangerously wrong. For over 50 years, since the last bootprints of Apollo 17 sank into the regolith in December 1972, humanity believed it had a firm grip on the nature of our nearest neighbor. We called it geologically dead. We called it airless and barren and simple. 6 missions landed on its surface. 24 humans walked its gray plains. We brought home 842 pounds of rock. We declared victory and went home. But we only ever saw one face. Think about that. Every single human who has ever lived, in every era of recorded history, has seen exactly the same side of the moon. Every poet who wrote about it, every sailor who navigated by it, every child who pointed up at it, they were all looking at the same hemisphere. The other half, roughly 14.6 million square miles of ancient, cratered, geologically alien terrain, had never been seen by human eyes from close range. Not once, until April 6, 2026. On that day, 4 astronauts aboard NASA's Orion spacecraft swept around the far side of the moon on the Artemis II mission. And what they encountered in those silent, radio-dark minutes shattered every comfortable assumption we had built. Not with the drama of explosions or alien life, but with something far more unsettling. The sheer, overwhelming complexity of a world we thought we knew. The crew was historic before they even left the ground. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen. For the first time in human history, a woman, a black astronaut, and a non-American citizen were traveling beyond Earth's orbit. The weight of that moment, cultural and scientific, was almost too large to hold. They lifted off on April 1st, 2026, at 6:35 p.m. Eastern Time from Launch Complex 39B at Kennedy Space Center in Florida. Beneath them was the Space Launch System, NASA's most powerful rocket ever built. The SLS Block 1 stands 322 feet tall, taller than the Statue of Liberty. At the moment of ignition, it generates 8.8 million pounds of thrust, more than the Saturn V that carried Apollo astronauts to the moon 5 decades ago. Within 5 minutes, they were out of Earth's gravitational embrace, already committed to their trajectory. There was no turning back. Their flight path was engineered around a principle called free return. On a free return trajectory, the physics are on your side. Even in the worst-case scenario, even if every engine on the spacecraft fails completely, the gravitational tug of the moon will swing the ship around like a slingshot and send it back toward Earth automatically. It is the safest path to the moon. The crew of Apollo 13 flew this same type of trajectory in 1970 after an oxygen tank explosion crippled their service module. They survived, but only just. Artemis II would swing around the far side at an altitude of approximately 4,670 miles above the lunar surface. Not landing, not yet. A proving flight. A chance to test the Orion capsule's systems in deep space with human lives aboard. And in doing so, they would accomplish something no crew in history ever had. Fly directly over the far side of the moon and observe it with human eyes. The silence. At 6:44 p.m. Eastern Time on April 6th, something happened that hadn't happened to any human crew since the Apollo program. The signal died. Not a malfunction. Not an emergency. The moon itself, 3,474 kilometers of solid rock, passed between the spacecraft and every antenna on Earth. No radio signal can bend around that. Houston fell silent. Telemetry screens went dark. Mission controllers, who had been monitoring every heartbeat, every cabin pressure reading, every thruster firing, suddenly had nothing. The crew of Artemis II was alone. Not alone the way astronauts on the International Space Station are alone. Orbiting 250 miles overhead, a few seconds radio delay from contact. Not alone the way deep-sea submariners are alone, hours from rescue, but still on the same planet. The Artemis II crew was alone in a way no humans had been since 1972. Alone on the other side of the moon, moving at over 2,000 miles per hour, with no signal, no backup voice, no mission abort command. 40 minutes of total silence. Victor Glover had been trying to describe what he was seeing in real time, transmitting observations back to Houston before the blackout window closed. But as the shadow line of the moon's limb crept toward blocking his signal, he found himself struggling with language itself. Later, his words became famous. "I don't think humans have evolved to see something like this." He said it quietly, almost to himself. He admitted it was something profoundly difficult to translate into words. And then the signal cut out. 4 human beings in a capsule, roughly the size of a large SUV, sitting above the most cratered, most alien, most silent landscape in the known solar system. For 40 minutes. Alone. What they saw was not the moon you know. The other side of the world. To understand what the Artemis II crew encountered on the far side, you need to first understand just how radically, shockingly different it is from the hemisphere we've always watched. The near side, the face that stares down at us every night, is dominated by large dark plains called Maria. These are ancient lava flows, oceans of basalt that erupted billions of years ago and flooded enormous craters left by early solar system bombardment. They cooled, solidified, and left flat, dark expanses that make up about 31% of the near-side surface. When you look at the moon and see the dark patches that humans have turned into rabbits and faces in their imaginations, that's the Maria. That's lava. That's ancient volcanism. On the far side, there is almost none of that, less than 1%. The far side has barely any Maria at all. Instead, it is a nearly unbroken expanse of impact craters, piled on top of each other in layer after layer, stretching all the way back to the late heavy bombardment 4 billion years ago. Looking at it from orbit, it appears almost texturally different, more densely packed, more chaotic, more wounded. If the near side is a scarred but partly healed battlefield, the far side is a record of every blow, every catastrophe, never softened. The crust on the far side is also approximately 50 kilometers thicker than the near side. This asymmetry has no definitive explanation. The leading hypothesis involves a catastrophic ancient impact near the South Pole, so violent that it sent a thermal pulse rippling through the moon's interior, redistributing heat-producing elements and permanently altering the geological balance between the two hemispheres. The near side, warmer for longer, produced more volcanic activity. The far side, colder, preserved its wounds. But the most staggering feature of the far side isn't visible from the surface. It isn't even visible to the naked eye. It's buried. The scar that almost ended the moon. In the southern reaches of the far side lies the South Pole Aitken Basin, the largest, deepest, and oldest confirmed impact crater in the solar system. It spans approximately 2,500 kilometers across. If you placed it over the continental United States, it would stretch from the western edge of Texas to the Atlantic coast of Virginia. Its rim mountains rise as high as 8,500 meters. Its floor plunges 13 kilometers below the surrounding terrain. Whatever hit the moon to create this basin didn't just make a hole, it rewrote the moon's geology. And something from that impact is still down there. In 2019, a team led by planetary geophysicist Peter James at Baylor University detected a massive anomaly lurking at least 300 kilometers beneath the surface of the South Pole Aitken Basin. not at the surface, not in the shallow crust, deep in the mantle, buried under mountains of geological time. This anomaly has a mass of at least 2.18 quintillion kilograms. James described it as equivalent to a pile of metal 5 times the size of Hawaii's Big Island, compressed and buried hundreds of kilometers underground. The gravitational effect of this mass physically deforms the basin floor, pulling it downward by more than 1.5 kilometers. The most scientifically plausible explanation? It's the metallic core of the asteroid that created the basin. The projectile hit so hard and so fast, likely exceeding 20 kilometers per second, that instead of melting and dispersing, its iron-nickel core punched through the crust and lodged in the lunar mantle, where it has remained for 4 billion years, like a bullet fragment still buried in the wound. The crew of Artemis II flew directly over the eastern edge of this basin. Unlike every orbital probe or robotic mission before them, they had human eyes, with the full range of depth perception, color sensitivity, and intuitive geological recognition that no camera or algorithm can fully replicate. Christina Koch noted that newer craters stood out with startling brightness against the ancient surface. She compared them to tiny punctures in a lampshade, pinpricks of brilliant white against dull gray, fresh wounds. Against the 4-billion-year-old surface of the basin, a crater formed 10 million years ago counts as brand new. The anomaly that shouldn't exist. In 2023, researchers published findings about a thermal anomaly detected beneath the lunar surface. An area roughly 50 kilometers wide was found to be approximately 10 degrees Celsius, warmer than the surrounding terrain. The source of this heat was identified as a massive block of granite. Granite. On the Moon. On Earth, granite forms through a very specific geological process. Water-rich magma, driven by plate tectonics, cools slowly and differentiates into coarse-grained igneous rock. This process requires water. It requires tectonic movement, conditions that, according to everything we thought we knew, do not exist on the Moon and have not existed for billions of years. And yet there it is, still warm, still radiating heat from whatever volcanic process created it perhaps 3.5 billion years ago, like a coal from a fire long dead that somehow never fully cooled. Geoscientist Matt Siegler noted that this discovery suggested lunar geology may resemble terrestrial processes far more closely than previously assumed, which raised a question that no one in 2026 had planned to ask. What else is still warm down there? Then there are the lava tubes. Radar data from lunar orbiters has revealed vast networks of hollow subsurface tunnels formed billions of years ago when flowing lava created channels beneath a hardened crust and then drained away. On Earth, lava tubes rarely exceed 30 meters in diameter. On the Moon, where gravity is 1/6 as strong and volcanic flows were far more fluid, some of these tubes may extend hundreds of meters across. Orbital imagery has captured skylight pits, where the ceiling has collapsed, and the shadows within them suggest cavern spaces large enough to shelter entire city blocks. The structural integrity of these tubes is unknown, their true dimensions are unknown, and whatever they contain, preserved gases, pristine volcanic deposits, temperature conditions radically different from the surface, remains completely unexamined. The whirlpool of light. Before the crew swung around to the far side, they passed over one of the near side's most inexplicable features, Reiner Gamma. It doesn't look like any other geological formation in the solar system. It appears as a bright, swirling pattern on the dark basaltic plain of Oceanus Procellarum, a ghostly white brushstroke, a cosmic fingerprint pressed into the volcanic rock. It has no elevation, it casts no shadow. It is not a crater, not a ridge, not a flow, a flat optical marking that changes the way light reflects from the surface without changing the surface's physical shape. and it sits directly above one of the Moon's only significant magnetic anomalies. The Moon has no global magnetic field. It hasn't had one for billions of years. Its iron core cooled and stopped generating the planetary dynamo. But scattered through the lunar crust are islands of magnetized rock, remnant patches that preserve the ghost of a field that once existed, like iron filings magnetized long ago and frozen in their orientation even after the magnet was removed. The current leading hypothesis holds that this remnant field deflects the solar wind just enough to alter the weathering pattern on the surface. The area under magnetic protection ages differently, accumulates different particles, reflects light differently, hence the bright swirl. A bruise from solar wind that wasn't quite delivered. But scientists aren't certain. The Artemis II scientific team designated Reiner Gamma as a priority observation target, and the crew photographed it extensively. Those images may finally answer what this object actually is, or they may open new questions. The Terminator's magic. Victor Glover found himself transfixed by the Terminator. On the Moon, the boundary between the sunlit hemisphere and the shadow is not a soft twilight gradient. There is no atmosphere to scatter the light, no haze to soften the transition. The Terminator on the Moon is a razor edge. One side, brilliant, bleached sunlight. The other, absolute darkness so total it appears as a physical substance rather than an absence. Along this line, the lighting geometry creates something that has to be seen to be believed. Craters that would appear as simple circular depressions under overhead illumination transform into something otherworldly. The sun hits them at such a low angle, nearly grazing the surface, that it illuminates only their rims, while their interiors plunge into shadows so deep they appear to have no bottom. From orbit, they look like bottomless holes, literally, as if you could fall through them to the center of the Moon. Glover radioed back to Earth. The Terminator is full of some kind of magic. Sharp light and deep valleys look like black holes you could fall right through to the center of the Moon. He was not speaking poetically. He was describing a visual phenomenon that the ground science team immediately flagged as a priority observation, because the way shadows fall along the Terminator encodes information about crater morphology and surface texture that can't be extracted from any other viewing angle. Human eyes detected details that even the best orbital cameras had partially missed. The crew of Artemis II was doing geology with their eyes, in real time, 250,000 miles from home. Meanwhile, Christina Koch and Jeremy Hansen were focused on photographing the crater Avlov, positioned on the rim of the ancient Hertzsprung Basin, deep on the far side. In Houston, the scientific assessment team continuously revised the observation plan, sending new instructions as the crew's reports came in. The crew also noted color variations on the surface, subtle browns, greens, and faint blues, that cameras had smoothed over. These color signatures indicate mineral composition and rock age. They could rewrite geological maps of the entire Moon. The eclipse. No one has ever seen. Then came the event that none of the crew expected to be the most overwhelming of the entire mission. As the Orion spacecraft slipped behind the Moon, the sun, seen from this position, this angle, this altitude, slowly descended behind the lunar limb. The Moon eclipsed it. Completely. The solar corona, the outermost layer of the sun's atmosphere, extending millions of miles into space, normally invisible behind the blinding photosphere, blazed into view as a halo of structured light. Streamers and plumes and plasma arcs, each one larger than Earth, framed the absolute black disk of the Moon. The total phase of this eclipse lasted nearly 54 minutes, a record for human observers. Glover described the corona as bright enough to outline the entire circumference of the Moon simultaneously. Hansen reported that it backlit every mountain and ridge along the lunar limb, the silhouetted peaks of ancient crater rims, creating a jagged, dark skyline against the searing white of solar plasma. Then Hansen and Wiseman saw something that stopped their breath. Flashes on the surface. Brief, brilliant, millisecond pulses of light in the shadow of the moon. The most likely explanation: meteorite impacts. Small pieces of debris hitting the unprotected lunar surface at cosmic velocities, releasing bursts of kinetic energy that briefly heat the surface material to incandescence. A flash, gone in an instant. Scientists at Mission Control immediately asked for confirmation. Both pilots affirmed they had witnessed at least one bright, short flash. These events, called transient lunar phenomena, have been reported by Earth-based observers for centuries. Monks at Canterbury in 1178 described seeing the moon split in two. Their origins have been debated for decades. Some are meteorite impacts. Some may be electrostatically lofted dust clouds. The Artemis II crew may have witnessed one in real time, with their own eyes. This same radiation environment had been working on the 4 astronauts themselves from the moment they left Earth's magnetic protection. The Apollo crews knew about it. They reported seeing light flashes even with their eyes closed. Phosphenes caused by high-energy cosmic ray particles passing directly through the vitreous humor of their eyeballs and triggering the visual cortex. Not radiation sickness, but a reminder: your body was not designed for this environment. The invisible killer. The moon is bathed in radiation, constantly, relentlessly, in ways that make every long-term human presence there an act of profound biological courage. Earth is protected by 2 things: its magnetic field, which deflects charged particles from the sun and cosmic rays from the galaxy, and its thick atmosphere, which absorbs whatever gets through. The magnetosphere extends tens of thousands of miles into space, creating a cocoon that we have lived inside for our entire evolutionary history. The moon has neither of these things. Its global magnetic field died billions of years ago. Its atmosphere is so thin, technically an exosphere, that the pressure at the lunar surface is approximately 3 times 10 to the -15 atmospheres. For practical purposes, there is no atmosphere. Measurements from NASA's Lunar Reconnaissance Orbiter show that the radiation environment on the lunar surface is approximately 1,369 microsieverts per day, roughly 200 times the average daily dose on Earth's surface. During a major solar particle event, this can spike catastrophically. The Artemis II mission launched during solar maximum, the peak of the Sun's 11-year activity cycle, when the risk of major solar particle events is at its greatest. The Orion capsule has significantly better radiation shielding than the Apollo command modules, and it includes a dedicated shelter area where crew can cluster during a solar event. But no spacecraft currently in operation can fully shield against the most extreme events. Dr. Alessandra Stankovic at Massachusetts General Hospital leads research into the long-term biological consequences of deep space radiation. Her work demonstrates that galactic cosmic rays, particularly the heavy ions, cause damage to neurological tissue that is fundamentally different from the X-ray and gamma-ray damage that medical science has studied most intensively. The heavy ions are like microscopic bowling balls traveling at the speed of light. They don't just ionize molecules, they shatter them, leaving tracks of destruction through cells that can affect cognitive function, memory, and emotional regulation. We have data from 24 humans who flew to the moon. That's it, 24. Statistically, that is far too small a sample to draw conclusions about long-term health risks. Some Apollo astronauts developed unusual rates of cardiovascular disease in later life, a finding suggesting deep space radiation may damage blood vessels. But the sample size means correlations have wide error bars. We simply do not have enough data. Artemis II carries an experiment called Avatar. Samples of the crew's own bone marrow cells, stored aboard the spacecraft, that will be analyzed after return to measure how living tissue responded to the deep space radiation environment. This is not about this mission specifically. This is about building the biological database for Mars. During those 40 minutes of radio silence on the far side, if a major solar particle event had erupted, Mission Control would not have known. The crew would not have received a warning. 4 people. A capsule the size of a large SUV. The far side of the moon. An invisible storm of radiation from a star 93 million miles away. And silence. The ground that bites. When Artemis II eventually lands on the surface, the astronauts will encounter a second silent hazard that engineers have been quietly anxious about for decades. The regolith. Lunar regolith is not soil. It is not dirt. It is the result of 4 billion years of micrometeorite bombardment, cosmic ray bombardment, and thermal cycling turning solid rock into a layer of powdered glass. Each grain is sharp, irregular, and covered with nanoscale glassy protrusions. There is no water, no wind, no biological activity to round those edges the way Earth's processes round quartz grains in a river. Every single particle is a microscopic razor blade. This matters because the regolith doesn't stay on the ground. Electrostatic charging, driven by the same solar wind that creates the radiation environment, causes regolith particles to levitate, not metaphorically drift, actually levitate. Lunar dust has been observed by orbiting spacecraft as a permanent haze above the surface, maintained by the continuous charging of the solar wind. During sunrise and sunset, as the terminator sweeps across the surface, this levitation intensifies. The Apollo astronauts discovered this the hard way. By the end of their first moonwalk, the regolith had worked into every seal, every joint, every mechanism. It scratched visors. It abraded suit material. Apollo 17 astronaut Jack Schmitt suffered from what he described as lunar hay fever, a reaction to inhaled or ingested regolith particles that caused sneezing, congestion, and irritated mucous membranes. If you're on the surface long enough, the dust finds a way in. Smaller particles, those below 20 micrometers, are the most dangerous. They can reach the deep alveoli of the lungs if inhaled, lodging in tissue that has no mechanism for clearing them, potentially causing a condition analogous to silicosis, the progressive, incurable scarring of lung tissue caused by inhaled crystalline silica particles. Silicosis has killed tens of thousands of miners throughout history. The regolith of the moon is, in some respects, silicosis made into a landscape. The cascading catastrophe. Here is what really keeps mission planners awake at night. Not any single risk in isolation, but the way these risks combine. The moon doesn't kill you with one thing. It kills you with a cascade. Imagine the scenario. A future Artemis surface crew is conducting an EVA several hundred meters from the habitat. The solar weather forecast was nominal at departure. Then, without warning, because space weather forecasting is still imperfect, a moderate solar particle event erupts. An alarm triggers. The crew must return immediately. On the path back, one astronaut's boot catches in a regolith patch with unexpected consistency. Ice mixed, different density, unexpected give. The fall isn't dangerous by itself, but the suit glove makes contact with the surface, and microscopic regolith particles embed near a joint seal. The seal is not broken, but over the next several hours, as the suit cycles through pressure changes, that contaminated region works against itself. Back in the habitat, the crew receives their elevated radiation dose, not critical, but adding to their cumulative mission total. The suit is inspected. The contamination is logged as non-critical. But over the following weeks, that joint continues to accumulate microwear. In cold shadow, when temperatures drop to minus 173 degrees Celsius, the material stiffens more than nominal. On a subsequent EVA, that stiffness becomes relevant during a critical task requiring precise grip force. A tool is dropped. In 1/6 gravity, it bounces. It lands in a shadow. The crew takes additional time retrieving it, extending the EVA beyond the planned duration, drawing down suit consumables that also serve as emergency backup. That's the cascade, not an explosion, not a single catastrophic failure. A chain of small degradations, each individually manageable, collectively creating a situation where margins disappear. And on the moon, margins are everything. There is no mountain rescue team. There is no emergency hospital. The backup plans have backup plans, and when those run out, there is nothing. The Apollo program understood this viscerally. Apollo 13 happened not because of one catastrophic failure, but because a seemingly minor manufacturing defect triggered a sequence of events that nearly killed 3 people. The lesson is not that NASA recovered heroically, though they did. The lesson is that the moon finds the vulnerabilities you didn't know you had. The body in space. Radiation effects begin immediately beyond Earth's magnetosphere. The first thing the Artemis II crew would have noticed is the flashes. Particles hitting the retina. Seeing things that aren't there in the dark with your eyes closed. An astronaut's visual cortex firing in response to ionizing radiation traveling through their skull. It doesn't hurt. It just flickers. A reminder that the environment is passing through you, literally through you while you sleep. The cardiovascular system begins to adapt to microgravity within hours. Fluids that gravity normally pools in the lower body redistribute toward the head and chest. The brain registers what it thinks is excess blood volume and reduces fluid production. Mild dehydration of the cardiovascular system, reduced plasma volume, a heart that begins to lose conditioning because it no longer pumps against gravity. Bone density loss begins within the first weeks. Without the constant mechanical loading that Earth's gravity provides, the simple act of standing, walking, carrying your own weight, the specialized cells that maintain bone density receive no signal to continue their work. In a 6-month ISS mission, astronauts lose an average of 1 to 2% of bone density per month in weight-bearing bones. On the moon, with 1/6 gravity, this process proceeds more slowly than in 0G, but it does not stop. The vestibular system, the inner ear's gyroscope, your body's mechanism for telling up from down, is profoundly confused in altered gravity. Space adaptation syndrome, nausea, disorientation, vomiting in the acute phase. In the chronic phase, subtle changes in spatial reasoning, depth perception, fine motor coordination that may persist throughout a long mission, and the long-term effects of cumulative galactic cosmic ray exposure are still being characterized. The heavy ion component appears to affect prefrontal cortex function specifically, the seat of executive decision-making, impulse control, risk assessment. Mouse studies show measurable changes in maze navigation, response to novel situations, and fear suppression months after exposure. We have not confirmed these effects in humans. The Apollo dataset is too small, and no human has been to deep space long enough for the effects to manifest clearly. But the question is being asked, and no one has a confident answer. The mind at the edge. There is a dimension to all of this that the medical checklists don't fully capture, what it does to your mind to be this alone, this far, with this much at stake. The Artemis II crew had the advantage of movement. They were flying past, not staying. Their 10-day mission had a defined return trajectory. They knew they were going home. The psychological burden was present, but bounded. Now imagine the perspective shift that a surface mission would impose. You are on the moon. You are 384,400 kilometers from every other human being. The communication delay is 1.3 seconds one way, manageable but noticeable. Over time, this makes real-time conversation feel subtly wrong, like a room with a slight echo. It frays the emotional texture of communication. The habitat is cramped. Everything smells of recycled air and human bodies, and the faint burning smell of regolith brought in on suits. There are no sunsets, no weather, no birds, no ambient sound, because sound doesn't travel through vacuum. Isolation, confinement, monotony, and existential distance are the psychological ingredients that have been studied in Antarctic winter overcruise, submarine crews, and long-duration ISS missions. What emerges is a consistent pattern. Interpersonal friction escalates after several weeks. Decision fatigue increases. Cognitive performance on complex tasks degrades, and something researchers call the third quarter phenomenon occurs. A significant dip in morale and performance at the three-quarter mark of a long mission, as the novelty has faded and the end still feels distant. On the Moon, these pressures operate in an environment where every significant decision carries life or death weight. You cannot afford cognitive degradation when the difference between a good decision and a poor one is the difference between coming home and not. Victor Glover, who had spent 6 months aboard the International Space Station, described the Farside overflight as something categorically different from anything he had experienced in low Earth orbit. The ISS, for all its isolation, is close to Earth. You can see city lights below you. Radio contact is continuous. The psychological tether is intact. On the far side of the Moon, in silence, looking at a landscape no human had ever seen, the tether was gone. "I don't think humans have evolved to see something like this," he said. He was right. We haven't. Our brains developed in African savannas, fine-tuned for parsing social dynamics, detecting predators, calculating short-range distances. Nothing in our evolutionary history prepared us for standing at the edge of a 100-kilometer impact basin on the backside of the Moon, while the radio is silent and every other human being is on the other side of a rock. What China found. While the world was watching Artemis II, it's worth remembering that humans are not the only ones exploring the far side. China's Chang'e 4 mission landed in the von Karman crater, a 186-kilometer-wide impact basin within the South Pole Aitken Basin itself, on January 3, 2019. The first soft landing on the far side in history. To make it work, China launched a relay satellite called Queqiao, Magpie Bridge, to a halo orbit around the second Earth-Moon Lagrange point, where it could maintain line of sight with both the lander and ground stations on Earth. Without that relay satellite, the mission would have been impossible. The Moon's bulk blocks all direct communication. The U-22 rover has since traveled over 1,900 meters across the farside terrain, far exceeding its designed operational life, and detected olivine and pyroxene in the regolith. These are mantle rocks, materials that normally reside deep beneath the lunar crust. Their presence on the basin floor is direct evidence that the impact that created the South Pole Aitken Basin was violent enough to excavate through the entire crust and throw mantle material across the surface. The Moon, literally, was turned inside out. In 2024, China's Chang'e 6 mission accomplished something many had considered impossible. It landed on the far side, collected samples, launched an ascent vehicle, performed a rendezvous and docking in lunar orbit, and returned those samples to Earth. The first far side samples in human history. Preliminary findings include isotopic compositions that differ from the near-side samples returned by Apollo, confirming that the two hemispheres represent fundamentally different geological histories. The telescope. Only the Moon can build. There is one more reason the far side matters, a reason that has nothing to do with what's on it and everything to do with what isn't. Radio noise. Earth is surrounded by a cocoon of electromagnetic interference. Television broadcasts, cellular networks, GPS signals, radar emissions, satellite communications, Wi-Fi, a constant roar that drowns out the faintest cosmic signals. The far side of the Moon is the only naturally radio quiet zone within easy reach of Earth. Shielded by 3,000 kilometers of solid rock from every human-made signal, it offers an observational environment that cannot be replicated anywhere else in the inner solar system. From there, you could detect the cosmic dark ages, the epoch before the first stars formed, when the universe was filled with neutral hydrogen gas slowly beginning to clump and heat. This era emitted radiation at specific radio wavelengths completely inaccessible from Earth's surface. Detecting this signal would allow astronomers to directly observe the universe's first structure forming, not infer it, see it. The Lunar Crater Radio Telescope proposal envisions deploying a kilometer-wide wire mesh antenna in a natural crater, creating the largest filled aperture radio telescope ever built. It would see things no other instrument in human history has been able to see. The far side of the moon is not just a dangerous alien landscape to survive. It is also the finest observatory site that civilization has ever identified. The homecoming and what it means. When the Orion spacecraft emerged from behind the moon after 40 minutes of silence, mission control erupted. Controllers who had maintained professional stillness for hours broke into applause. Voices that had stayed calm through everything suddenly became human. The crew had one more thing to tell them. As they came around the lunar limb and Earth came into view, they witnessed Earthset, the Earth, seen from the moon's horizon, slowly sinking behind the lunar mountains as their trajectory carried them past. Christina Koch described it with words that have since been quoted around the world. When you see home that small, you understand how important it is to take care of it. She added, Earth is everything we have, our only oasis. You can only truly understand that when you're 250,000 miles away. During the overflight, the crew named 2 previously unnamed craters. The first they called Integrity, the informal name the crew had given to the Orion spacecraft throughout their training. The second they named Carol, in honor of Carol Taylor Wiseman, Commander Reed Wiseman's mother, who had passed away before seeing her son make history. The crater called Carol sits exactly on the boundary between the near side and the far side of the moon, bright, prominent, visible through a good telescope from Earth. Jeremy Hansen described it as a bright beacon on a harsh landscape. Artemis II set the record for the farthest humans have ever traveled from Earth, 252,756 miles, more than 400,000 kilometers. The total observation period over the lunar surface lasted 7 intense hours, during which the crew photographed thousands of frames. The full archive will be extracted from the spacecraft's hard drives after splashdown in the Pacific Ocean, and it will become the foundation for selecting landing sites for Artemis III, the first crewed lunar landing since Apollo 17. Those images will be analyzed by hundreds of planetary scientists. Understanding the surface texture, the shadow geometry, the regolith properties, the slope angles of the south polar terrain is not abstract science. It is survival planning. An astronaut who steps onto a slope, they misjudged because orbital photos flattened. The perspective is an astronaut in danger. The human eye caught things on this mission that algorithms had smoothed over. That will translate directly into safer future missions. The deeper truth. We have spent a great deal of time cataloging what the moon will do to human bodies, human minds, and human machines. And all of it is true. The radiation will accumulate. The regolith will infiltrate. The gravity will take its toll on bones and hearts. The isolation will test psychological limits. The cascade of compound failures will keep engineers awake for years. But we are going anyway. Not because we are reckless. Not because we underestimate the danger. Because the alternative, staying, retreating to comfortable familiarity, treating the boundary of Earth's atmosphere as the boundary of human experience, has costs of its own. The science that requires the far side of the moon cannot be done from Earth. The resources that make long-duration exploration possible exist nowhere else within reach. The understanding of how the solar system formed, how Earth itself came to be livable, that understanding lives in rocks on another world that we have not yet fully touched. The moon, it turns out, is not solved. It is not known. It is not finished. Victor Glover was right. We haven't evolved to see this, but we went and looked anyway. The South Pole Aitken Basin is stranger than our models. The thermal anomalies suggest processes we haven't explained. The magnetic remnants in the crust record a history we lost. The lava tubes await in darkness. The radio silence that astronomers dream of is real, and the small blue world visible from the far side, fragile and alone against the vacuum, is everything that we have and everything that we stand to lose. This great journey into the unknown has only just begun. We are only at the start of the greatest adventure in human history, and we are watching it happen in real time. I hope you enjoyed the video. If you did, please give it a thumbs up. It genuinely helps this channel reach more curious people who want to understand our universe deeply and honestly. Subscribe so you don't miss the next chapter of this extraordinary story. There is so much more to come. See you in the next one.